you ever been at an amusement park and you get in line and you go through all the lines and you turn the corner and you get to a whole nother room of lines and you finally get to the front of the line, and you know how exciting it is to be at the front of the line at the amusement park and you're next? You know how that feels? You know how cool it is to be next? You know what's really cool? We're next. We get to do this. This is going to be really cool. This is the definitive deep dive into the .git folder. And what's really cool is this talk has no slides. That's it. The definitive deep dive into the .git folder. We're going to open up the .git folder and we're going to look at each of the files in that folder and talk about what they do. So we're not going to run all of the Git commands, but we will get to experience all of the storage mechanisms of Git, all the way that it saves content in Git. So let's take a look at that. Let's start by popping open this folder. And this folder currently is empty. We don't have anything in this folder right now. Let's make it into a Git repository. So I'm going to say git init. Now when we say git init, we create a new empty Git repository. Probably in the way that we've traditionally done it. Instead of doing a git init, we do a git clone, which behind the scenes does an init and then a pull. And so we'll just not do that pull part yet. And so I still have an empty folder. Well, kind of. I have this .git folder. Now I chose to come in here to view options, and I chose to show hidden files, and so now I can see the .git folder. If you're on Mac or Linux, then anything that starts with a dot is hidden by default, so you probably won't see it straight away. But if you do an ls-la, then, which PowerShell is going to interpret and get all mad about, then you'll actually see the .git folder. And that .git folder has a lot of stuff in it. And this is the Git database. So if you want to talk about, well, how do I back up a Git repository? You back up this .git folder and you get all of the stuff. Now what's in here? Well, we have hooks, info, objects, refs, config, and we'll take a look at each of those. If I were to open up this outer folder here in VS Code, I would get a whole lot of nothing. And that's by default. When VS Code goes to show us the files, it excludes the things that typically would be hidden, of which this is one of them. So I'm not going to open up that folder. I'll open up this .git folder inside of VS Code, and let's take a look at the content that we have here. Yep, there's all the files and folders that we have. And for the most part, all of them are empty right now. We'll fill them up as we go. Hooks has a few more things in it. But yeah, we've got a pretty empty database. That's cool. We just initialized an empty Git repository, and we will now start filling it full of stuff. So let's first start with echo file1 contents. I'm going to send that to file1.txt. And now we have a file. Cool. Did anything happen in our Git repository yet? Nope. We haven't done any Git operations yet. So let's commit this file. So next up, we could, let's say git add file1, git commit -m, initial commit. Why do we always have to call the initial commit initial commit? Could we make a more descriptive initial first comment? I don't know. First comment. Cool. So we have this file1.txt. We have inside of our .git folder, we have now, oh, some objects. Nice. We have some stuff in our Git repository. We have these files here. If we do a git log, we can see that our first commit is DAA69F6127E and a bunch more. Oh, here's this DA folder. That's kind of cool. And here's this A69 something. Yeah, there's our first commit. See? Clear as mud. This content is actually zlib compressed. And so because it's zlib compressed, if we just pop it open in a text editor, it, well, looks like that. So let's unzlib compress it. Well, all the tools that we're going to see are up online right now. Here's this gist. The URL is gist.github.com/robrich/ ready to memorize the git hash? An easier way to get to this git hash is to come here to robrich.org, robrich.org, click on presentations, and the definitive deep dive is right here. Here's a link to that gist. So all of the tools that we'll get to see, all of the content is right here on this gist. And so the notes, in addition to the slides, are already online right now. Achievement unlocked. Have you ever been in a talk where they say, I'm definitely going to post the slides to my site tonight? How's that worked out? My slides are online right now. While we're here at robrich.org, let's click on About Me and we'll see some of the things that I've done recently. I've gotten a few awards from Microsoft and from Docker. I'm a friend of Redgate. That's really fun. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. On Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in London or wherever you traveled from, find me here at the event or on any of the socials, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I got to work on a few books. That was really cool. I run a few user groups in the States. And one of the things that I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments on the air, and they sent me a mug. Woohoo! So there's my claim to fame. I have a coveted .NET Rocks mug. And if you'd like a .NET Rocks mug, you can submit a comment on the website, and they will not send you one of these. They'll send you music to code by. My coveted .NET Rocks mug. Cool. So that's a little bit about me. You can go to robrich.org and you'll get to this gist, which will list all of the things that we're going to see today. The first thing that we want to see is how do we unzlib compress this thing? So how do we unzlib compress it? Well, I found the Stack Overflow article that lists a lot of really interesting things to do it. We can use OpenSSL to unzlib compress it. That's kind of fun. Here's a Perl script. Here's a Python script. There's Git tools to do it as well. I built this really cool thing. I call it Unzipper. It's this one node app that just quickly goes and grabs the thing, uses zlib to inflate it, and it will just split by nulls so that we can see all of the contents in this. Okay, so let's use Unzipper. Unzipper ./.git/objects/ we saw this one was DA, and let's unzlib compress this. Okay. Do you remember when you said git config -- global user.email and user.name? You did that like when you first installed Git. This was like 400 years ago. You bet you don't even remember that was a thing. That's where they ended up at. You know, we've got my author name, my author email. We also have the date time together with the time zone. That's the commit message that I put in. Here's also the commit message right here, initial commit. And what's interesting is there's 187 bytes in this whole thing, and it is a commit. That's kind of cool. Oh, it references this node. I remember that, 7.2. Here's that 7.2 folder. Let's unzlib compress that. Unzipper.git/objects/7.2. Okay, so here's the zlib decompressed version of this node. And so it's a tree node that is 317 bytes. It's listing file 1. Here's the file permissions. And unfortunately, this part is double zlib compressed. So let's actually use git cat file. That'll help us do some stuff. Cat file dash T 7262EA, and that is of type tree. Cool, we got the type of that one. We could take a look at our other one and look at that one, DA A6, and it is of type commit. Okay, let's look at the contents then of that one. So instead of dash T, we will do dash P, because of course content starts with the letter P. And now we can see the contents of this one. So here's the file name. It's a blob. Here's the file permissions, and here's the hash of that blob. So let's do git cat file dash T 84D5. And that is a blob. We knew that. That's where the file is stored. And so let's git cat file dash P 84D5. And we can see that there's the contents of my file. So we had the commit node. We had a tree node that specified what files were part of that commit. And then we had a blob node that stored the actual contents of those files. So we kind of see that nice progression. A commit always references one tree node, but a tree node may reference other tree nodes depending on folders, and then ultimately tree nodes reference blob nodes that have file contents. So let's do that again. Echo file2, we'll send that to file2.txt, git add file2, git commit -m file2, and git add file2.txt, git commit -m file2, and now we see that we have a whole bunch more nodes. We have a new commit node for that new commit. We have a new tree node that references the files in that, and we have a new blob node that represents the contents of file 2. Well, we could get cat file each one and start to understand how those work, but that's a little weird. So what if we could visualize these? Well, I built this program called Git Explorer that allows us to be able to visualize not only those commit nodes, but also the tree nodes and the blob nodes underneath. And so this Git Explorer is in this list of tools. Here's Git Explorer. And so let's fire up Git Explorer and take a look at it. You point Git Explorer at the folder where your .git folder is. And then once it starts this web server, we can now come here and take a look at our project. So, do I want to run node? Yes, I do, because apparently I haven't run node before. Okay, here's my 6 commits, my 6 nodes in this objects folder. So here's this one. Okay, that's the blob node. Here's a tree node. Here's another tree node. Notice that we have 2 files. Well, let's take a look at this and see if we can show the type. That might help us. I just randomly assigned colors to these. So red is commits, blue is tree, and blob is green. So we can take a look at these commit nodes. Here's the commit. It looks like that's our initial commit. Here's our second commit. We can see that it not only references the tree node, it also references the parent node. That's kind of cool. So now that we've got this tree 2b, let's show the, there's 2b. So here's the 2 files in that folder, and file 1 and file 2, and they reference this blob node 6c. Here's 6c, and there's the contents of file 2, as opposed to here, which is the contents of file 1. So maybe instead of just kind of having them here, let's do this and we'll show the tags. Now we've got all of the commit messages, and now we can kind of cruise through it a little bit better. So here's that initial commit. It references this tree node 2b. Here's this tree node. It references these files. Here's file 1 at 8.4, and so there's 8.4. And now we can get a feel for the contents of it. Cool. Or if we want to do kind of more of a parent-child view, we can do that. And we can draw the lines and the tags. And so here's that commit, and it references this file, which references these two blobs. Oh, Git reused the other blob. The other file didn't change. It didn't need to save another copy of that file. It just, linked to it. That's kind of cool. So let's do some more content here in our repository. I'm going to come back over here, echo file3. We'll redirect that to file3.txt. Did we change our repository at all? Nope, we still have 6 nodes. Okay, git add file3. Have we changed our repository? Show the type, parent, child, show the line, show the tags. Oh, we added it to the staging area, and it added an object to our objects folder inside of Git. It stashed the file inside of our staging area. Have you ever staged something and then continued to change it, and then you had to stage it again? Yeah, because it copied it here into this zlib compressed spot to be able to catch it. Okay, cool. So we've got this staged. Now let's commit it. Git commit -m file3, and we will save that, come back here, and let's refresh, show the type, show the lines, show the tags. Oh, parent child, now show the tags. There we go. Oh, cool. So our latest commit references this tree node that happens to have 3 files in it, this file, and this file. We haven't needed to change a file yet, so we haven't created any new nodes. Part of the magic of Git is that it stores everything as compactly as possible. The history of the Python project is about 20 years of commits and changes and adjustments. And the .git folder for the Python repository is smaller than the checkout directory for the Python repository, because it's, the Perl repository. That history is humongous, but Git is so good at storing things very compactly. Okay, so let's do some interesting things. Let's go change a file. So here's our Git folder. Let's open up file3. And let's say file3 is modified. And of course, we have to have the right number of semicolons and some curly braces. Oh, we need to close the curly braces. Excellent. Git add file3. Wasn't file3 already in our repository? Why do we need to add it again? What we're adding here is not the file into source control, we're adding the changes into the staging area. We are staging these changes. So we added these changes into our repository. Okay, git commit -m file3 mod, and let's come back here and let's show the type, parent child, show the lines, show the tags. Oh, cool. Here's our new commit. It references this parent commit. It references this tree node, so there are 3 files in our directory right now. This file, which is file3 that is modified, and this file 2, and this file 1. Cool. So what if we put a file in a folder? So I'm going to create a new folder. Let's call this folder folder. And let's grab file 2, and let's copy it into this folder. And now let's take a look at it. Git status. Okay, we have that folder. Git add folder. Git status. Okay, we've committed that. Git commit -m file 2 in a folder. There we go. Now that we've committed that, we can take a look at our git log, and we can see nothing. Git log --1 line. And now we can see that we've committed that file. Let's come back over here and refresh, show the type, parent child, show the lines, show the tags. Here's our new commit that references this tree node, which by the way happens to include a tree node. We have a folder within this folder. Here's this inner folder, which by the way references this file 2. You notice we still only have 4 blob nodes. File 1, file 2, file 3, and the change file 3. We don't need to store another copy of the file just because we moved it. If I moved the file and you changed the file, there is no merge conflict because the blob is only changed by you. I changed the tree. Isn't that cool? Git is really good at storing stuff. Okay, so I'm coding along. I'm here in file 1. Yeah, let's add more code and add some more code. Really important function here. Okay, so let's git add file 1, git commit -m. Really important change. Let's take a look at this. Refresh, show the type, parent child, show the lines, show the tags. Let's take a look at our latest commit. It references this tree node, which has that nested folder, but I'm after this blob right here. Oh. Oops. I committed a secret. Now what? It's 5 o'clock on a Friday. I just want to go home, man. Can I just ignore it? Can I force push? How do I get this gone? Well, we could do some stuff. Actually, let's do this. I learned about this new thing recently. It's called amend. So I'm going to come in here and I'm going to delete my secret. That looks great. Git add file 1, git commit -m. Really important. Don't look here. And then if I just committed it, it would add another node on top and I would show that I had added it and then removed it. No, I want to hide my thing. -amend. Cool. I have changed the commit. It is gone. Git log, --1 line, and okay, it's gone, right? Show the type, parent child, show the lines, show the tags. Here's my new commit. It references this tree node. It references this file. There is no secret there. That looks great, except for that. Git is really good at storing stuff. If you commit a secret, it is lost. It's lost. You need to rotate the key. Any thoughts or concerns here? But I haven't pushed yet. It's only on my local machine. You probably have one of these settings in your IDE as well. Oh, it's not going to show it to me because I'm inside the repository. But there's a thing that says automatically push branches and automatically sync changes. So it's probably pulling changes from others. It's probably pushing up your personal branches. You probably did push. And maybe if you caught it in time, maybe you're okay, but it is probably gone. Oh, I'll just force push and then it'll be gone. No, if somebody pulled after you pushed before you force pushed, it's still there. If you have committed a secret to Git, that secret is lost. Your only option is to reset the key. Yes, on Friday at 5 p.m. I'm sorry. One of the things that I really like to do is when I'm here in my git commit window, I'm going to very specifically look through each file. I'm going to look at the diff for each file. I'm going to go looking for these code smells, code I didn't mean to commit, code that I meant to commit in a different thing to a different branch. And I'm very specifically going to look for secrets so that I don't commit secrets. I'm going to spend a lot of time here in my commit dialog crafting that commit, telling the story to my fellow developers. If you've committed secrets, it's gone. Cool. So we have here in our objects folder, we have tree nodes, we have commit nodes, we have blob nodes. A commit is what we typically look at. Commits reference tree nodes, which is that folder structure and file permissions. And those reference blob nodes where we have our actual content. And if we change the content, we get a brand new file that includes the entire thing inside of our blob nodes. Any questions on objects?
Can we not just delete the blob from the folder?
Ooh, good idea. Can we not just come in here and into our .git folder, into objects, go find that particular object and just delete it?
And update the tree.
This node, if we were to delete this node, then this tree node references a commit that doesn't exist, a blob that doesn't exist, and now our Git repository is corrupted. Which means it's going to keep trying to find that object in other repositories. It's going to pull from other repositories. It's going to try and find it and put it back. And in the meantime, your tree is broken. The only way to break Git is to futz with files here in the .git folder. And so yeah, technically you could go delete that node, and now you're left with a broken database. Great question though, I love that. Every time I do this talk, everyone has a new idea of how we can, avoid rotating the keys. I don't want to rotate the keys. Yeah, I don't either. The way to solve that is not to commit them. Cool, we did the objects folder. That is awesome. Git log -- one line. We have a main thing here. That's cool. How do branches work? Well, let's take a look inside this .git folder. And we did objects. That was great. Let's take a look at refs. We have this head thing. Oh, head. Cool. Head references refs, heads, main. Okay. The refs folder, a heads folder, a main file, 48AF. 48AF, ooh, that's the commit message. This head is a pointer to the ref that it points to. So in this case, main. And main is a pointer to the ref that, in this case, a commit. And so these are just files in there. So what if I wanted to say git log, move my head to this commit. Now I did say the only way to break Git is to change the files, and I'm, doing things badly. So let's do git log, and now main is over there. This is not the way to switch branches. Git status. Check out all these untracked files because I just picked this thing up. Do not pass go, do not collect $200 and plop down over there. Yeah, so let's not do that. But that's what branches are. They're just labels, human readable labels towards commits that we can do there. So git status, everything's fine. Git log -- one line, we're back at the top. Excellent. So what if we did want to switch to that other one? Let's git checkout this. Git checkout there. I am in a detached head state. Is this a Halloween thing? How did I lose my head? This is a really, really scary looking message, and it's kind of a benign concern, but let's take a look at what this was. Previously, when we opened up head, it pointed at refs heads main. Now it points at a commit. Git still works just fine. We can come in here and we can say echo file4, redirect that to file4.txt, git add file4, git commit -m file4, git log -- one line. Git still works great. Oh, where's the other ones? Git log -- one line -- decorate. Decorate will add the branch names to me. So, I actually have that set in my global one so that it will always do that. Git log -- one line -- graph -- decorate. That will show me the ASCII art there on the left, but I still am not showing things that aren't part of my branch. So let's do git log -- one line -- graph -- decorate -- all. And now we can see the tree. Head is doing fine, it's over there. Main is going this way, and we can see that commit history work out just fine. Git checkout main. Git log -- one line -- graph -- decorate -- all, and that commit is gone. Where's file 4? Well, we could go back into that Git Explorer and we could go find the commit of where that was, and we could start to wander through it and be able to get at it. But from here, it's kind of gone. Let's come back to that one. Let's go find file 4 in a minute. Git checkout, git branch, new branch, and I'm going to create that new branch down here. Git log -- one line -- graph -- decorate -- all, and we can see that we now have not only a main, but also a new branch. Let's pop open that repository inside our refs folder. We now have a new head that points to this commit. Okay, that's cool. Branches are just other things inside this refs heads folder that points to a different commit. How do tags work? Git tag v0.1, I'll tag main right now. And we can see that there's a tag. And back here inside refs, we see now there's a tags folder. Here's v0.1, and it just points at that commit. All of these branches and tags are just labels, just name tags that we can give to various commits to make them more easy for us to find these commits. Well, what about remotes? Let's come here into, we're here in this Git folder. Let's create a new folder next to it, and let's say new folder server. And so now I'll open the second terminal in this server. And let's create a Git repository here. And then we'll link them, and now we get to play with remotes. Now, typically we're up on github.com or maybe Bitbucket, and we go create the repository, and it does this behind the scenes. But let's do it here. Let's say git init -- bear. Now, last time we just said git init. This time we said git init - bear. And when we say bear, it doesn't create the .git folder. It only creates the contents of the .git folder. This is perfect for servers where we don't have a checkout directory. We just want it to keep the history there. And so -- bear with no working directory is perfect. It's just the contents of the Git folder. So now that I have that server, let's come here. If ever we did a new repository with git init, and now we need to hook up to a server, we can say git add remote, and let's give it a name. By default, we tend to call this origin. And we could say https github.com, and that then creates a link to that server. They could be on a URL, and typically we do it that way, but they could also be on SSH to something, or sometimes we say git plus SSH, or we could put it on a file share. So path server, path to repo, and that works out just fine as well. Or we could do it as an absolute path on our machine. So C program files. I'll probably need to put this in quotes and we can put that repository there. Or in my case, I'm just going to give it a relative URL. It's up one folder in the server folder. Cool. A URL, a remote path, a local path, or even a relative path. So git add remote, I did this wrong. Git remote add origin, and we'll give it a path. And now we can take a look at this. Git remote -v, and here's the remote that we've done. So let's say git push origin new branch. We've now pushed this content into that remote server. So if we look at the remote server and look here in the objects folder, we saw all those objects. We've now pushed all those objects up into that remote server. If we look in the remote server's refs folder, we can see that we now have the new branch up on the remote server too. Cool. How do we represent this now locally? Well, we have this refs folder. We have a heads folder, tags folder. We saw that previously. We now have a remotes folder. For each remote, in our case, we happen to call it origin, we have all of the branches pushed to there, and here's where that remote server's branch is. Well, the last time I saw it. So now if we do a git log --one line --graph --decorate --all, we can see not only the green local branch, we can see the red remote tracking branch. Where is it on the server? Now we only pushed that branch so far, so let's push some more things. Git push origin main, and now we can see that main is on the server too. We now have that red remote tracking branch. Here in the Git repository, inside the remotes, inside origin, we have the main file pointing at where that is too. Whether they're tags or branches or even head, which isn't in the refs folder for some reason, they're all just pointers to commits or pointers to other branches or tags. Any questions on refs? Yeah.
Does it have to point to a commit, or it can also point to a tree or a blob?
Ooh, good question. Does it have to point to a commit, or could it point to a tree node or a blob node? It must point to a commit node. But now I want to try it. I want to see what happens. Not while I'm on stage today, but I want to see if I can break Git by pointing at a different type of node. I know if you point it at a node that doesn't exist, it gets all kinds of mad. That's brilliant. So we have this ref. Remember file 4? Where's file 4? Maybe we have a log of the refs where we can kind of take a look at this. So let's take a look at the logs here. And we have here in the logs folder, we have a refs folder. Oh, this looks good. So let's take a look at where the main branch was. Well, it started out at nowhere and it moved to this commit by this person on this date. And then it moved from here to here, and from here to here, and from here to here. We have one for each of the branches. Here's the main branch, the new branch, the remotes branch, and we also have a log of where head has been. Now, in most of these cases, head was where we were, so that's great. Let's go look for file 4. File 4, oh, not there. Here, file 4. Oh, okay, so there's that commit. We created that file 4 commit here. Okay, so git check out that commit. Git log --one line --graph --decorate --all, and there is file 4. Git kept it. I don't have to retype all my work. Okay, we're back in this detached head space though. How do we get out of this detached head? Well, what detached head means is that head is not pointing at a ref, head is pointing at a commit. So how do we undetach it? How do we reattach it? We create a new branch here. Git checkout -b branch 2. And now we are no longer in a detached head state. Now head is pointing at a branch. If ever you get that detached head state warning, that's just a warning that says you need a branch here. Once you check out a branch or create a branch or move a branch or merge this into a branch, you will be out of the detached head state. Reflog is really helpful. Git reflog will also tell us that thing. And so git reflog is probably the way that you want to browse through the reflogs. I've also heard it called reflog, git reflog. I can just imagine somebody with a whip going, whoosh. No, it's not reflog, git reflog. And it's called git reflog because it's a log of where the refs have been. Cool. Refs. Any questions about refs or logs or objects? Anything in Git so far? Yeah.
Going back to your git amend example, what would happen if you've done a git reset to undo the commit?
Ooh, what would happen if I did a git reset to undo the commit? Let's do that. Let's say git reset. We're here on branch 2. Git log -- one line -- graph -- git reset back to before I did this branch. And now branch 2 is back before that commit, so now file 4 doesn't exist at all, right? Show the type, parent child, show the lines, show the tags. It's still there. Over time, Git will start to clean up the history. You can set it, but by default, it's 2 weeks. If you have something that is unattached for 2 weeks, it will get cleaned up. Are you sure nobody's going to clone your repository for 2 weeks? I've seen people commit AWS keys just to see, push them up on GitHub, no tweet, no message, no anything, just some random public repository where they just happen to push one commit an hour. Somebody was logging into their AWS account within an hour. If you have pushed keys, the only way to safely proceed is to rotate those keys. That was a great idea, though. I love that.
And if you haven't pushed?
If you haven't pushed, your software may have pushed for you. It's really easy in both SourceTree and VS Code and also Visual Studio to turn on the auto sync feature, in which case it probably pushed up your personal branches without you even knowing it. I like to turn those features off because, yeah, I'm like, no, don't leave my machine until I'm ready. But you probably have them on by default. If I run the cleanup, it hasn't been 2 weeks yet, but let's do that. Git GC, there's the cleanup. Show the type, show the lines, parent child, show the tags. Yeah, it's still there. Git reset -- hard. Good idea. The cool part about git reset -- hard is git reset -- hard, if you don't pass it a commit, it will just delete all of your local changes that you've staged or all of the staged changes that you haven't committed yet, which is great. But, and so, my commit is still here, git status. It didn't delete file 4 off my local machine, but it is still inside the repository. Show the type. Oh, show the type, parent child, show the lines, show the tags. It's still there. Yeah, hard is good at losing changes you haven't committed. It's not good at losing changes you have committed. Good idea, though. That was awesome.
Git filter branch.
Git filter branch. Ooh, we're going wizardry here. Git filter branch is really good at rewriting history. And if nobody's cloned it yet and you can get everyone to buy off on doing that, then that might be a decent way to rewrite that commit out of the piece, out of the middle of the thing. But if there's one copy of that thing still there, yeah, you filter branch to rewrite the history, but, and I don't know how many times I've done this. I do a git filter branch to like rewrite it and clean it up. And one of my coworkers just says, merge. So now we have the clean one and the dirty one coming back together. And I'm like, did you miss the entire point? Yeah. Cool. We've looked at refs. We've looked at objects. We've looked at logs. Let's take a look now inside of hooks. Now, hooks is a really cool thing. Here in the hooks folder, there are a whole bunch of files that are example files. They all end in .sample. And this one's a shell script. This one is a shell script and a shell script. And one of these is a Perl script. Did I go right past it? But they're just things that get run when various events happen. And so if I were to rename this file and remove the .sample part, then it would run. It's part of these hooks. So they're great for automation. I'm going to come in here and I'm going to just reach into the other oven and I'll pull out a whole bunch of hooks here that I made previously. I won't put them in the server. I'll put them here in our local one. And now in each of these, I echo what method we're doing and the arguments that were passed to that method, just so that we can get a feel for how these hooks work. Now, these hooks are great for automation. I can say, hey, run all my unit tests for everything I staged, or run my linter for everything before I push. Or if ever you've committed to Netlify, or you've committed to Azure Web Apps and you have that kudu prompt and it's doing a whole bunch of stuff where it's going like this and running interesting things, those are post-commit webhooks that are doing interesting things. So let's do this. Git status. Oh, we have a file 4. Git add file 4. Git commit -m file 4. And we can see a bunch of hooks. We have the pre-commit hook, we have the prepare message hook, we have the commit message hook, and those were all the things that ran as part of this process. And with each one, we can see that one of them was passed the file name that it needed, one of them was passed various parameters. We could rewrite the message according to our corporate validation rules. We could also harvest interesting things. Let's see if this works for our release notes. Let's see if this commit message follows our standard practice. Or maybe let's kick off the tests locally and validate that our system can compile. Git push origin branch 2. And we can see that now we have some pre-commit hooks. We could run some post-commit hooks that might do some deployment to a particular server. And so that's really cool, where we can take a look at each of these pieces and do various automation tests. Now, one of the things that I'm really bad at is remembering to run my tests before I commit, or to run linting before I commit. And so that's great, where I have these hooks and I can build up this automation so that as I'm doing my Git tasks, it can do all of those things for me. This automation is really cool. So I've got these hooks that I want to do. And so let me see, git add.git/hooks/ let me commit that apply patch message hook. Git status. We can't commit things inside the Git folder. In hindsight, that completely makes sense. If I were to be able to commit things inside the Git folder, perhaps I could commit a branch name, or an object, or a reflog, some file that needed to change in my database. So we can't commit the hooks. What we can do, though, is we can move these hooks to another place. So there's this git hooks package with npm that allows us to be able to create a symlink from some other folder, they just call it .git-hooks, into that hooks folder inside the Git directory. And with that symlink, now we can commit them. We've moved these full files outside of that .git folder. So Git hooks is great for Node, or you could use Husky. Python uses pre-commit. PHP, you can use PHP Git hooks or Grum PHP. There's a shell script called Git hooks, or there's a really cool gist there. That Git hooks shell script was turned into a Go app. You can also do a git config to move that in an interesting way if you don't want to pull in one of these external packages. The downside though is if you do this config path, you need to tell all your coworkers to do that config path too. And inevitably, the new guy's not going to and not going to get that automation. So one of the things that I really like about Git hooks is it's a post-install step that rigs up this link. And so as soon as they do npm install, then they have that Git hooks automation wired up. And oh, by the way, they had all the other things. The C# community generally uses pre-commit, the Python one, or finds another tool. You could use a .NET tool to be able to rig up that symlink as well. Yes?
You can still add the pre-commit hooks, for example, and they will be on remote even without those tools. And every person checking the repo out will still get them.
They'll still get the files in that other directory, yes?
They will not be executed by default.
Right, they will not be executed by default until you create that symlink that puts them, the junction that puts them in the correct folder such that Git knows that they're there. Yeah, you're right. All of these tools don't get those files into the repository. They get the symlink so that those files get executed by Git. Thanks for that clarification. Cool, so lots of automation that allows us to do really interesting things with Git hooks. Any questions on Git hooks or the automation here? What languages are supported? Anything that runs in a shell. So all of their examples are bash scripts, except for one that is a Python script. But I've also run Node apps just with, /bin/node. I've also run .NET apps. You could run a Go executable, just anything you can run from a shell script. It just has to be named exactly that. Great question. We've done hooks, we've done logs, we've done objects, refs. Let's talk about configuration. This description file. This file is so hilarious. Built into Git is Git InstaWeb, an early prototype of a Git server. I bet you've never used it. I've never used it as well. It's built into the Mac and Linux clients because of Linus, but it isn't built into the Windows client because apparently Windows is hard. But Git InstaWeb, this is the description that shows up in the website that it creates. Gee whiz, that's kind of cool. That's the description. We've also got, orig head, that's a temp file. We've also got this config file. This is a nice config file. Now the cool part, this is the configuration associated with this repository. Now this isn't the only config file that Git is going to use. Git is also going to look from this local file to the global file that is across your entire profile. So let's go open up mine. It's in my home directory, and it has a whole bunch of settings. This is global because it's specific to my user because naming is hard. It's global to all of my repositories, but it's not global to my machine. And then I have a system one, and that system one is in the spot where Git is installed. And that is all the options that I chose when I installed Git. So we start with the system one, and then we overlay over the top of it our global one that is user specific. Remember when you said git config -- global? User.email and user.name? See how they're in the global section there? And so that global config takes effect for all the things. And then our local config can take effect for this specific repository. So what if I have a scenario where I'm doing the majority of my stuff open source, I want to use my personal email, but then I want to be able to do some corporate stuff, so I want to use my corporate email. Well, I can come here and I can go grab this section out of my global config, and I can put it here in my local config. And now commits that I do in this repository will have my corporate email address instead of my global email address. So that's one way that you can change configuration in interesting ways. Now, one of the things that I did here in this global configuration file, other than user.name and user.email, my GitHub details, my editor, I wanted to pop open VS Code instead of VI. VI is actually really a wonderful tool. If ever you need a random number generator, put a junior developer in front of VI and ask them to quit. It is amazing. It's really cool. If ever you get into one of these Git dialogues where you have just a colon over on the far side of the screen, you're in VI. The magic sauce is Q exclamation point, and now you're out. Okay, we'll come back to aliases. Those are really fun. My diff tool and my merge tool are configured here. Ooh, help autocorrect. This is really cool. Have you ever done one of these things where you say git stas? I have my help set to 8, which means 0.8 seconds. And it's going to say, did you actually mean this? And I'm like, why, yes, thank you. And so that autocorrect can be really helpful in being able to do stuff. So that's this help section right here. What version and what is my credential manager? That's kind of fun. Auto stash, that's cool. Let's come back to aliases. Aliases are fun. You know how we were typing git log -- one line -- graph -- decorate -- all? You know how we typed it like a lot of times? We can create aliases. So I created myself this alias that says git hist. So instead of typing git log -- one line -- graph -- I've already forgotten what my command was -- all. Instead, I can just say git hist and it will do the same thing. Now, it's really easy to abuse aliases and make Git feel like the tool you used before Git. Please try to avoid that. Get familiar with the Git commands and then build aliases that help you with that. So for example, have you ever been, ready to do something and then you switch over to your code editor and you start doing something else? And then you come back and you do a git status? Okay, what wizardry did we just do there? I have an alias that says, if you run git, I would like you to start a new shell and run the rest of the arguments as a new shell. Which means that works just fine.
How many shells have you started?
1, 2, 3, yeah. It starts a new shell every time. But that is a really helpful alias for me. I've also created some aliases from time to time to guess how many commits are in it. ls_ignored is really fun. Show me all of the things that are in my repository or in my checkout directory that are excluded by my gitignore file. Account, if they really want to know, so how many commits is it? I have some interesting aliases. Cool. Next up, let's take a look at index. Now, index is kind of interesting. It's this big binary blob, and it's kind of a mess to read. If we wanted to, we could come look at this app, Gin, to be able to look at it. It's a Python program that parses it. Here's a Stack Overflow thing that's like, well, how do you read it? And it starts talking about, well, here's all the pieces in that thing. This index is an index of all of the files in your working directory related straight to the blobs associated with that. So there is a built-in command to do it that's actually the easiest one to do it. Git ls files, let's do that. So git ls files. Here's all the files in my working directory and which blob hash last committed it. This makes stuff like git status. Really easy because it just goes, okay, so here's all the files, here's all of the hashes. If I rehash this file, does it still have the same hash? Okay, it's changed. That index makes that process really fast. So that's that index file right here. We have a few more interesting index files. There's an index file because we chose to run git gc, not there, objects. Our objects is a lot smaller. We packed them into this pack file, and we end up with an index file for the pack file too. Now that pack file is a zlib compressed archive of all the commits, just so there's less files on disk. But whenever Git needs it, it just unpacks those pack files, and that works out really well. So there's an index in there with the same format. And then temp files. Now we have head, which is as expected. But when we saw the commits go past, we saw it passed in this .commit/edit message. That was the temp file that one script passed the other script so that it could modify that and come back. And so we'll see various temp files here. Here's orig head, a temp file that just happened to be present because it wanted to pass from one script to another. Commit message, we might see other temp files in here. Packed refs looks like it's one of those temp files that just happens to kick around in the outside directory. There's that commit edit message file that it passed from one to the other. So we've got some temp files in here. Refs is for storing the branches. Objects is for storing the commits, trees, and blobs, all of the content. Reflog is how we can look up where ref was. We have some hooks. Oh, the exclude file. This exclude file is pretty cool. This is a list of files that we will never commit in our repository. Don't we have a .gitignore file for that? Yes, we do. And this git exclude file is another way to do exactly that, but you can't commit this file because it's inside the .git folder. So I would invite you to forget what this exclude file does. This is not the place to ignore files that you don't want to commit. But that is all the contents of the .git folder. We have objects, including commits, trees, and blobs. We have refs that point to those objects. We have configuration that allows us to be able to automate how we do that. We have hooks that allow us to be able to run certain shell scripts when events happen. And then we have a bunch of index and log files. Here's a great post that kind of walks through all of the pieces. Great reference for this. And when I did this talk previously, a good friend of mine, Eric Potter, built this infographic that describes exactly that. Here's each of the types of files, and here's what each one does. All of this is available here on this gist, which you can get to really easily from robrich.org and dig into all of the things. This has been a lot of fun getting to share with you the definitive deep dive into the .git folder. Thank you for coming. Any questions? Yes?
What do promise objects look like?
What do promise objects look like?
Promisor.
Promisor?
Yeah, yes. I think that's how they're pronounced. So
I'm-
if I do a partial play, and I don't download all the blobs from the remote, but I have a promisor object that gets lazily initialized.
Yes, a promisor object. For the most part, from what I understand, it is a commit node that references another node that doesn't exist. And so it's not unlike these. It's just that it has a special tag right there in the parent so that it knows that, my repository is not broken.
Okay.
I've never heard it called a promisor object, though. Now I'm curious. I'm going to go figure that out.
That's from the Git repository.
Yeah.
So.
Cool. Thank you. Other thoughts or questions here? Yes?
When we had the detached blob, what would happen if I create the same file with the same contents? Would it create a new one or detach the old one?
Ooh, what happens if I have the exact same file with the exact same contents? Will it create a new commit? let's take file 4 and let's copy it. And let's say file 4, I'm going to take out the spaces just so it's easier for me to type. Git status, git add file 4, git commit -m, copy of file 4. There, we did that. Here's our automation hooks. That looks great. Let's come back in here, show the type, parent child, show the lines, show the tags. Here is our new commit that references the exact same file 4. If I commit the same file and it is exactly the same, it doesn't need to store a second copy of it. Yeah. Yes?
Can you show us the Git folder after when you introduce some modules?
When I do submodules in Git, the short answer to submodules is if you have a problem that submodules is the correct solution for, find a different solution to this problem. The wonderful thing about submodules is it is a file in your repository that references a different repository. But it doesn't just reference a different repository, it references a specific commit in that repository. So you have to git pull in your repository, and then you have to go into that submodule repository and git pull in that one too, which is really unexpected. So probably using a package manager is a lot easier, but ultimately that file is not inside this .git folder, it's just a file committed to your repository out there. So yeah, it is a curious file, but it's out of scope for today. Great question though, I love that. Yes?
What's the point in exclude versus ignore? Just legacy.
What's the purpose of exclude versus git ignore? Git ignore is a file you can check in, exclude is a file you can't.
So why would you use exclude?
I'm on a server, why would I use exclude? I'm on a server, I want to have some local configuration file that I definitely don't want to conflict with my Git repository. I don't want it to try to merge it, I don't want it to check it out, I just want it to exclude it. But I don't want to commit that as part of the repository because it's only here on this server. So I might use my exclude file for that. But in most cases that we can kind of think through where we can come to the conclusion that exclude might be a good fit for this, it's like, well, why don't I just ignore that file and git ignore file? Because when I set up server number 2, I'm going to have to remember to futz with that thing, and now I'm back in Pulumi or Terraform futzing with setting this file in this repository, but maybe the thing hasn't been cloned yet. And yeah, so for the most part, like submodules, if you have a problem that requires the exclude file, find another solution to the problem. Great question, though. I love that. Awesome. Thank you for coming. This was a lot of fun.